Good afternoon, class. I guess you can tell I'm not there today, but of course, the class must go on. So we're going to continue with this little video lesson. As you'll see up here, I've got a picture of a quadratic or graph of a quadratic, and I want to know what the solution is. If you remember from Tuesday and Wednesday when we practiced solving quadratics, the 4 different methods, remember the graphing method? The graph indicated what the solution was based on if the quadratic crossed the x-axis or not. As you can see here, this quadratic does not cross the x-axis. So you were told to write no solution for this. So the answer for this would be no solution. But then when you were solving it, if you actually had to solve this out, you could try to factor it. You could try to complete the square. And the other method after completing the square was the quadratic formula. So those were your 4 methods: graphing, factor, complete the square, or use the quadratic formula. Well, as you can see, there's going to be no solution. So you're probably thinking, well, why even try factoring or completing the square or the quadratic formula when there's no answer? Well, the reason is there is an answer. It's just not a real solution. So the real answer to this, there's no real solution. There's still a solution, it's just not real. It's called an imaginary solution. So we're going to come back to this problem in just a few minutes. We're going to go ahead and go over, well, what is an imaginary number? All right, the complex numbers. So your goal today is you should be able to answer the following questions by the end of the lesson, hopefully. Explain what the value of I is. What is a complex number and why do we need it? How do you simplify square root with an imaginary unit? How can you multiply, add, subtract, and divide with expressions that have complex numbers, and compare that to expressions with nth roots? You're probably wondering what in the world that means. Basically, all it means is this. When you multiply, add, subtract, and divide expressions that have i's, you're going to treat it just the same as you would multiplying, adding, subtracting, and dividing expressions that have like x squares or x cubes or x to the whatever. It's pretty much the same rules that you follow. So that's all that means. A little complicated, but that's all it means. All right, why I? You're probably wondering, we've already got a real number system, so why in the world do we have to have an I? Well, and I'm not going to read all this to you, but basically mathematicians came to this problem here, x squared equals -1, and they're like, well, how can we solve this? How can we solve x squared equals -1? They know that to undo a square, you would simply take the square root, so you could take the square root of this side, take the square root of this side. Well, when you take the square root of x squared, it's just an x. But when you take the square root of -1, you're asking yourself this question. You're saying, what 2 numbers can I multiply and get a -1, and they have to be the same 2 numbers? So you might think, okay, well, 1 times 1, well, that's a 1. -1 times -1, well, that's also a 1. So there's no 2 numbers that I can multiply, and they have to be the same, that I'll get a -1. It can't do it. So they decided to describe this phenomena as, instead of x equals the square root of -1, they decided to describe it simply as x equals I. So I is really the equivalent. I is really the square root of -1. So that's what its equivalent is. And as far as usefulness, I know a lot of times you're like, why in the world do we have to learn this stuff? The best place I've found is in electronics. Engineers use it, and they study stresses on beams and to study resonance. You might end up seeing this possibly if you decide to be an engineer. You might see I's a whole lot. Electrical circuits and things like that. And it says, so if it weren't for I, we might not even be able to talk on cell phones or listen to the radio.